as you could probably expect, day 4 following day 3 is going to take what we did yesterday with parallel lines, and it's going to take it forth going into perpendicular. So difference between parallel and perpendicular is that perpendicular is going to have the slopes that have opposite reciprocals. So what that means is if we have, for example, y equals 1/2 x plus 4, opposite reciprocal. So reciprocal means you're going to flip it. So it would be 2, but it would change the sign. So it would be y equals -2x, say, plus 8. It really doesn't matter what the y-intercept is, but they will be perpendicular to each other. So, matching slopes. Well, that means that -1/4 and +4 are going to be perpendicular to each other. We knew yesterday that these were parallel to each other, so those don't work. We also have 5/2 and -2/5. Now, the question always comes up of 1 and 2/5. Remember, if you've got a mixed number, you won't see them very often, but to find the opposite reciprocal, you have to take this and convert it to a improper fraction, which would be 7/5. So the opposite reciprocal would be -5/7, which as you can see is not there. So basically when we talk about perpendicular lines, if we have a vertical line, its perpendicular line is going to be horizontal and horizontal is going to be vertical. So that means if you're given a y equals, say, 4 through a certain point, the perpendicular line is going to be x equals something through the x coordinate of the point you're given, and vice versa. So you might notice as we get into this first example that it's the exact same problem as yesterday, minus the one change that we're out talking perpendicular. And this is why we said it was so important yesterday to write down old and new slopes. So old slope is 1/5. We had that yesterday. But now the new slope is going to be the opposite sign and flip, which is going to be 5/1 or 5. So when we go into point slope form, which I'm going to remind you again is y minus y1 equals m times x minus x1, we're going to go ahead and put in the equation. And we have here y minus my y1, which is 3, times -5 times x minus x1, which is 2. So then we can distribute in, and we get y minus 3 equals -5x plus 10. And then we add 3, and we get y equals -5x plus 13. Some of you are going, oh my gosh, 13, that's going to go off our graph if you haven't figured that out by now. That's okay. We'll figure it out. It's not a big deal. So we'll graph the first one in blue. I usually like it if you color coordinate, if you're going to use colors, to let me know which one's which. So we go down 2, 4, 6, 7, and then we go up 1 over 5, up 1 over 5, and we connect the dots. And once again, if when you're graphing, if your lines are clearly not perpendicular to each other, please fix them. So then we go up 13, so we get 10, 11, 12, 13, and we go down 1, 2, 3, 4, 5, 4, 1, 1, 2, 3, 4, 5, 4, 1. And the question is, how far do you go? Well, you go until they intersect. So 1, 2, 3, 4, 5, 4, 1, 1, 2, 3, 4, 5, 4, 1. So now while we don't care right now what that point is of intersection, we do want to make sure that you make sure they intersect and don't just draw them and estimate. So as you can guess, our next one is our y equals 0.25 or 2500ths x plus 1 through -1, 2. So remember, we talked yesterday that this is the same thing as 1/4, because finding the reciprocal of a decimal, you can't do it unless you want to put it as 1 over 0.25, which doesn't work because you can't have decimals within fractions. So we know that the new one is negative, and it's flipped, so it's 4 over 1 or -4. So then we go ahead and put it into our equation. So y minus y1, which is 2, times equals negative 4 times x minus x1, which is negative 1, so x plus 1. Go ahead and distribute. Negative 4 times x is negative 4x. Negative 4 times 1 is negative 4. And then we have our y minus 2. So then we add the 2 to both sides, and we get y equals negative 4x minus 2. I'm going to graph my first one in blue. Start at 1, and we go up 1, forward 4, up 1, forward 4, and connect our dots. And then the next one we go down 2, and by going down 4, forward 1, I'm going away, so I'm going to go up 4, back 1, so that way I can make sure that I cross the other line. Now the last piece is being able to look at a set of equations and determine if they're parallel, perpendicular, or neither. So the first step of things, which if I haven't mentioned it already, if I write steps off to the side, you want to make sure those get in your notes because they're important. So if both equations are in slope-intercept form, convert them. If they are in slope-intercept form, then you're going to compare the slopes. If the same slope, then they're parallel. If opposite reciprocals, they're perpendicular. Otherwise, they're neither. So we look here. First one, we got a slope of 2/5 and a slope of 5/2. So a lot of you are going, oh, they're perpendicular. But wait, they're both positive. So in this case, this would be neither. So then the next one, they're both in standard form. So we need to solve for y. So we start by subtracting 12 on this one, and we get 2y equals 8x minus 12. And then we have to divide everything by 2, not just the slope. So that gives me y equals 4x minus 6. And then likewise over here, we're going to add 12x, which gives me 3y equals 12x plus 24. We divide everything by 3, which gives me y equals 4x plus 8. We aren't worried right now about the y-intercept. That's something that will be dealt with in 2.3. But I look here and I see I've got a 4 and a 4. So that must mean that they are parallel. So now that you've had a chance to see what those look like, let's go ahead and get some new tripod to shot. You got perpendicular, same equations as yesterday, just now perpendicular. And then we also have one question here at the tail end of being able to determine if these are parallel, perpendicular, or neither. And as always, bring your questions with you to class, but also feel free to put them in the class meet.